we are going to solve this equation by factoring and solving for all real solutions, which means we're going to take the entire unit circle plus 2 pi period for every solution we find in radians, and try to use the exact form when possible. So I can see this one is going to be a quadratic because I see a variable squared, variable single, and then a constant at the end. So this is in the form 3u squared plus 14u minus 5 equals 0, where I let u equal the cosine of theta. Now I need to solve that quadratic, and this one I'm going to do with the x method because I have a non-1 out in front. So I multiply the leading coefficient and the constant together to get negative 15. Let's do that again. So I have negative 15, and I want two numbers that multiply to negative 15 and add to 14. Actually, since they're multiplying to a negative 15, I'm really looking for a difference of 14, since I need one negative and one positive. When I add a negative and a positive together, I'm really looking for a difference. So that one is 15 and 1. I want a positive 14, so the smaller number gets the negative. So I'm going to replace this 14u with negative 1u and positive 15u. So that is a perfect replacement. And then just copy down the rest of minus 5 and 3u squared equals 0. Okay, now I'm going to do grouping. So I'll make let's do a green group, and there's a plus sign in the middle, so that's easy. And then let's do an orange group. So on the green group, looking at the GCF for this green group, I see a U. So that leaves me with 3U minus 1. And then the plus sign. And in the orange group, I have the greatest common factor there is a 5. So I'll take that out, and I'm left with 3U minus 1. And remember, my goal here is to get these two parentheses to be equal, which they are. And once I have those equal, I factor that whole thing out like it's its own variable, and I do 3u minus 1. And after I factor that out, I'm left with the u plus 5. That's the u and the plus 5. That multiplied together equals 0. So these are being multiplied together now, which means they're both factors, which means I can split it up. If two numbers are multiplied together equals 0, one of them must be 0. That's the zero product property. So I know 3u minus 1 equals 0, or u plus 5 equals 0. So I have two equations to get two solutions. On the left, I get 3u equals 1, adding 1 to both sides, and then I get u equals 1/3. And I get, that's actually a cosine, unsubstituting. So cosine of theta equals 1/3. So theta will equal cosine inverse, taking the cosine inverse of both sides of 1/3. In that equation on the right, I have u equals to negative 5, and then that is cosine theta equals negative 5. So theta will equal cosine inverse of negative 5. Okay, I'm going to shrink that up to give myself some more space here. So this guy, cosine inverse of negative 5, that says what angle gives me a cosine of 5? But I know that the cosine angle oscillates between negative 1 and 1. So it is never equal to negative 5. It's somewhere between, cosine of theta is somewhere between positive 1, negative 1. So this isn't possible. So this is an extraneous since cosine is between -1, why do I keep doing that? And -1 and +1. So that's out. So that leaves me with this little friend over here, and that is not a standard angle on my unit circle. So that's, I'm not going to be able to answer that in exact form without using the trig function. So in exact form, I keep the theta cosine inverse of 1/3, and I want all real solutions, so I know it's going to repeat every 2 pi. Plus or minus every 2 pi. So we'll call k an integer. But I can give, so that's one solution. That's the exact form. But I can give an estimated value of that using a calculator. So I get, let's see, cosine inverse of 1/3. So what angle gives me an x value of 1/3? Remember cosine, so it's going to be twice, right? 1/3 about here-ish. Thinking about my x value is 1/3. It's not going to be exactly on my unit circle, so don't get that confused with the pi/6, pi/3. But there is some angle here that gives me an x value of 1/3. It's not a standard angle, so I won't find it on my unit circle. So how I do find it is grab my calculator, and I will plug in cosine inverse of 1/3. So that's, make sure you're in radians. So I'm in radians now. And then I go the second key to get my cosine inverse, or a cosine or arc cosine, and I want 1/3. So I get theta is approximately equal to 1.23, let's round that 9 up to a 10, so we get 2310. And we still want to add 2 pi over k. So remember, when I use the calculator to get a sine inverse, it's only going to give me the principal solution. So since cosine is only defined on the top of the circle, top of the unit circle, that is this guy. So this is the x value right there. But there's another one, right? There's a guy that is exactly symmetry of him. So I can find him by saying this angle, this is almost 2 pi except short this angle. So that's 2 pi minus whatever that was. So that's 2 pi minus that angle that we just found. So that's 2 pi minus 1.2310. And if I could leave in the calculator like I have in the calculator still right now, that's the best way to go. So I'm going to make that a negative with this button here and add 2 pi. And that gives me a second angle, second solution for cosine of 5.0522. And again, plus 2 pi because it's going to repeat every period. So there's, I'm going to do these in a different color. Here, let me get rid of my calculator here. So I'll have my green exact solution here. But I also made note of a estimated value. So there's 2 solutions there. Whoops. So since I wasn't able to use the unit circle to find an exact answer without using the trig function, I did go ahead and use my calculator to estimate. All right, so these are my estimated. If this was a standard angle on my unit circle, that 1/3, then I would absolutely want a final answer in exact form. But because 1/3 is not on the unit circle, there's no x value of 1/3 on the unit circle, that's how I knew I needed to get a calculator and estimate it.